Welcome to the video for Chapter 7 for Honors Pre-Algebra. You'll notice at the top that all Chapter 7 assignments are due on January 25th, and there are a total of 5 lessons. I made a few changes for this chapter, so I'll be interested to hear what your feedback is for some of the changes that I've made. One of the changes is that your homework for this chapter will all be on worksheets. So notice right here that for lesson 7.1, the homework is lesson 1, homework practice. WS stands for worksheet, and that is paper clipped to your note sheets. So you're doing 2 through 38 evens, and you're still recording your score out of 19. There's a lesson 1 enrichment that you're going to be doing with me when I come to see you for this lesson. And then, of course, for each lesson after that, 7.2 has a worksheet. 7.3 has a worksheet. Just pay attention to the top of the worksheets because that's where it tells you whether or not it's a skills or a homework. So for example, homework for 7.1 is lesson 1 homework practice, whereas lesson 7.2 is a lesson 2 skills practice. But it's all labeled at the top of each worksheet so you know which one is your homework. If I scroll down here, notice that you have some IXL minutes from level K, lessons D1 through D8. That's just more practice on percents from chapter 6. If you ever run into a lesson that's taking you longer than 15 minutes, just let me know and you can move on. So just wanting you to make sure you practice those daily skills on IXL. Another change I made this chapter was to provide you with a little mini quiz after each lesson, and this will count as a summative grade at the end of the chapter. So you can either fill these lesson quizzes out as you complete each lesson, or you can wait until the end. It's up to you, but I will count this as a summative grade for this chapter. I'm going to minimize that and walk through a couple of things on the checklist. On the checklist, looks the same as it has in the past. You have 2 brain pops and 3 ed puzzles for this chapter, and you have those IXL lessons that you need to get 90% mastered. Another change I made is that during the ed puzzles, you'll notice that I have you stop and take notes on a note sheet. This is your Chapter 7 note sheet, and this first one is the ed puzzle, combining like terms and distributive property. Make sure you fill this out as you're watching the ed puzzles for Chapter 7. Here's another ed puzzle, adding and subtracting linear expressions. And so you might want to start this chapter by actually watching those ed puzzles and getting some background information. Okay, here's your third, no, it's not the third ed puzzle, it's just a continuation from the previous one. So make sure you are taking notes on these sheets as you are watching those ed puzzles because I will be taking a grade on those. Here are your links to the ed puzzles and brain pops, and you'll notice that I don't have a link to videos that I created. This is the one video that I'm going to create for Chapter 7, and I will go through problems from each of the lessons and then let you know what time marker to fast forward to if you want to watch a particular lesson. So everything else on the note sheet looks pretty much the same. So this hopefully will get you started on lesson 7, Chapter 7, and let me know if you have any questions. Next, I'll be going through each lesson, a couple of problems from each worksheet, explaining those problems. This video will go through the example problems for each of the lessons in Chapter 7, starting with lesson 7.1 on the distributive property. This whole chapter is a nice review of things we've already studied earlier in the year, so it's going to prepare you for the next chapter on solving equations and inequalities. So the key concept right there, the distributive property, make sure you understand both the algebraic way of representing that and also with numbers. Okay, of course when we have numbers here we can use the order of operations to take 9 minus 3, which is 6, and then 6 times 8, which is 48, but we also can take that 8 and distribute it to each of the inside numbers and get 72 minus 24, which is also equal to 48. So just make sure you're familiar with the distributive properties and ways that that's referred to in algebraic terms, and then actually with numbers as well. So if we're taking a look at the examples on page 292, at the bottom we're taking 4 times 6, which is 24, plus 4 times 3, which is 12, to get an answer of 36. Not sure why that's not working there. And then over here, 3/4 times 9 would be 27/4, okay? And 3/4 times 2 would be minus 6/4, and we could take 27/4 minus 6/4 to get 21/4. And of course we could rewrite that several ways because it's a rational number. We could divide it out, and 21 divided by 4 is 5.25, or 5 1/4. Any of those would be acceptable answers. On the next page, we're looking at example 2, where we have some story problems. For 2A on page 293, a spaghetti dinner at the Italian village costs $10.25. Use the distributive property in mental math to find the total cost of dinner for Sharita, her brother, and her parents. And so we have 3 people. Oops, excuse me. Let me get my pen here. We have 3 people, and we have $10 plus 25 cents. Now you might be thinking, do I really have to use the distributive property if I can just take 10.25 times 3? Absolutely. Just wanting you to know that there's more than one way to do these problems, and you could break up 10.25 into 10 plus 25 and then multiply 3 times 10 to get 30 and 3 times 20.25 to get 0.75. Okay, so 30.75 is what I have, but that's not what they showed here on the answer. So, probably because I wasn't counting her parents as 2 people. I was only counting that as 3 people. So you can see here we have 4 as that outside number, and then 10 and 25. 4 times 10 and 4 times 25 is $41. Sorry about that. All right, moving right along into the next part that shows how you can model distributive property using tiles. And these tiles exist, and you use things like this when you're in primary grades, when you first learn how to add and subtract. You can use them also with algebra. So take a look at page 293 and how those tiles are used. I'm going to go ahead and move forward to example 3 from lesson 7.1, and that's where we are starting to incorporate the variables. So on lesson 7.1, example 3A, we have 2.4 times A, which is 2.4A, and 2.4 times 5, which is 12. And then on on 3B, we have a little backwards action here. We take 3 times B, which is 3B, and 3 times 6, which is 18. Finally, on example 4, we are using the distributive property again. Don't let those fractions stop you. I'm still distributing them to each item inside the parentheses. 2/3 times D is 2/3 D, and 2/3 times -3 is a -2. Just practicing your basic multiplication of integers and rational numbers. -7 times E is -7E. Don't forget those negatives and negatives. When you multiply 2 negatives, you get a positive. So -7 times -4 is a positive 28. That's it for lesson 7.1. I'm going to go ahead and continue into lesson 7.2, and we will get those answers going in the same video. So for lesson 7.2, we're talking about combining like terms, and the definition of some of those basic things we've already taken a look at so far this year. I'll bring back to memory that we talked about terms and coefficients, those numbers right in front of a variable, and constants are those numbers that are hanging out by themselves. And we talked about simplifying by combining like terms. I also gave you words like monomial, and then we talked about binomial and trinomials and polynomials. That's based on the number of terms. So I'll be bringing up those words as we work through these problems in lesson 7-2 when we're simplifying algebraic expressions. So down here at the bottom of page 299, the like terms in this expression are negative 4x and positive 2x, and we also have a positive 2y and a positive 3y. So pretty straightforward there, just identifying the ones that are like each other. In example 2 on page 300, we are identifying the like terms, coefficients, terms, and constants. So right away I'm just going to verify or point out that we have a constant. That's the lone number hanging out by itself. The 2 is the constant. Okay, we have coefficients of 3, 5, and negative 6. And then we have like terms of 5m and negative 6m. That should take care of all of those for example 2. For example 3, we're simplifying expressions by combining like terms. So in 3a, we have 4x minus 3x, which is 1x. If you had a 1 there, that's also correct. And then we have a plus 6. For 3b, we have 2m minus 7m, which is a negative 2m. And we have a positive 3 minus 4, which is negative 1. This is called a binomial because it has two terms. There's one term, there's two terms. And in 3c, we have to actually use the distributive property first to get 4q plus 32p, and then we have this extra p here, which gives us 32p and 1p for 33p, and then that 4q. Again, a binomial because there's two terms. Moving on to page 301. At the top, there's one more example there with changing a story problem into words. And so for A, Mado and Lola both collect stamps. Lola has 16 more stamps in her collection than Mado. Write an expression in simplest form that represents the total number of stamps in both collections. Okay, so Mado is equal to my x. I don't know how much Mado has, but Lola has 16 more than Mado, so Lola is going to be x plus 16, and when you add those together, 2 x's, and then plus 16 is our answer. Derek has some stamps and has as many as Mado. Write an expression to represent the total of all three collections. So here is Mado, and Derek has the same as Mado, so Derek would also have x. So now we have a total of 3 x's and 16, which is what our answer is. That's it for lesson 7-2 on the guided practice or on the example problems. Hopefully that's enough to get you started on the worksheet for section 7-2. For 7-3, we're talking about adding linear expressions. And really, again, all we're doing is paying attention to positive and negative signs, practicing our integer rules, and combining like terms. So at the bottom of page 305, there's 2 example problems there for you to work out. We have 1x and 1x for a total of 2 x's. There's an x there and an x there. And then we have a negative 3 and a negative 4 for a negative 7. For 1b, negative 1x, take away 3x would be negative 4x. And then we have this plus 1 constant that does not combine with anything else. For example 2 on page 306, we are using models. Again, it's one way to represent the problem. It may or may not make sense to you, but do it how you would like and which makes sense to you. So for 2a, we have negative 2x plus 8x, which is 6x. Positive 4 minus 4 is 0, so there's no need to write that 0, just a 6x for that answer. For 2b, we have negative 4x plus 5x, which is a 1x. If you had a 1 there, that's not wrong. We just don't usually put the 1 as a coefficient. And we have a negative 1, take away 3 more, which is negative 4. On example 3, we have a perimeter problem demonstrated for us. And for the got it problem at the bottom of page 306, we have another one. Here's a rectangle. And it says that the side lengths are 5x minus 1 and 2x plus 1. Notice that I'm drawing a picture to solve this problem. Okay, the perimeter is all 4 sides added up. So I want to make sure and write in all 4 sides so I don't forget to add anything. I'm going to change my pen color here and say 5x plus 2x plus 5x plus 2x is 14x, and then the plus 1, minus 1, plus 1, minus 1 all cancel each other out. So all I have for the perimeter is 14x. And if they give us the value of x, we can substitute that in and evaluate it. 14 times 5.4 equals 75.6. On the next page here on 307, I think we have one more example at the top here. Actually, we don't. So that's it for lesson 7.3. Moving on to 7.4, which is subtracting linear expressions. Again, all we're doing is paying attention to those positive and negative signs and paying attention to details as we're trying to combine like terms. So in this case, on 1a, at the bottom of page 310, we have a minus 2x and a plus 1. So minus 2x plus 1. 7x minus 2x is 5x. Negative 5 plus 1 is negative 4. For 1b, if you distribute that negative sign, you get negative 2x plus 4. So 6x minus 2x is 4x, and then negative 4 plus 4 is 0. On the next page, we have some more subtraction problems. At the top here, we're using those models again with those tiles. If it makes sense to you, great. I do encourage you to spend some time learning different methods because that will always help you in different situations. On 2a, in the middle of page 311, we have, again, a negative to distribute. So that's a minus 2x plus 1. You're going to always make these kinds of errors because I still do after all these years of doing the problem. So just pay attention, take your time. X minus 2x is negative x, and negative 5 plus 1 is negative 4. For 2b, we have a negative times a negative 4m, which would be plus 4m, and a negative times a negative 1, which is a positive 1. 6m plus 4m is 10m. 3 plus 1 is 4. And finally, on example 3, we're looking at some story problems. After working X hours on Monday, Kay earns $9X. On Tuesday, she earns $7X plus $3. So write an expression to represent how much she earned on Monday. So what we're going to do is we're going to take $9X, take away 7X plus $3. And we have 9X minus 7X, which is 2X, and that minus 3 doesn't match with what I have shown here. So I should take my time here and write this out. 9x minus parentheses 7x plus 3. So you can see where I got the 2x because we get negative 7x. 9x minus 7x is 2x. But I did not distribute that negative sign to the 3. So it is 2x minus 3. If she worked for 5 hours each day, how much did she earn on Monday? So 5 is our X value, and after working X hours on Monday, we're going to put a 5 in for this, which is 35 plus 3, which is 38. And we put 5 in for 9x to get 45. And 45 minus 38 is $7. On the next lesson, I don't believe there are any more example problems for lesson 7.4. So we are ready for lesson 5, and that is on page 316. And I call factoring linear expressions doing the reverse of distributive property. So instead of distributing, we're going backwards, and that requires that we know how to find the greatest common factor. And if you remember earlier in the year, we did a method called the tower method. And so that looks something like this, where you draw a little tower there and pull out a common factor. And so if you pull out the 4, you have a 3 and a 7c left over. There's no common factor between 3 and 7c, so our greatest common factor is 4. On 1b, if I pull out a 5, what I have left is a 5x and a 3xy. And both of those have an x in common. So together, I pulled out a 5 and an x, or 5x. On number 1c, 42mn and 14mn. Maybe you didn't know that 14 was a common factor. So what you can do is pull out a 2. So let's say 2 into 42 is 21mn, and into 14 is 7mn, and you realize, oh, 7 is also a common factor. So I pull out a 3mn and a 1mn. Then I start looking at the variables. What do both of those have in common? Well, they both have an m and an n in common, and so what I have left at the top is a 3 and a 1, which are both have a factor of 1. So my greatest common factor would be everything that I pulled out, which is 7 times 2 times m times n, which is 14mn. And on page 317, we have some more examples to look through using a model. And there's that word for you to write down in your vocabulary, which is factored form. That's when an expression is expressed as a product of its factors. So product is a multiplication problem, and that's a product of the factors. And so let's take a look. Again, don't forget you have these video tutors that you can watch as well from the textbook. But let's jump down to example 2 in the bottom, towards the bottom of page 317. So what number is it that I can pull out of both 4x and 28? Well, it's that 4. And then what I have left is x plus 7. And you can always check your work by taking your answer and see if you get the original problem. So 4 times x is 4x. 4 times 7 is 28. For the next problem, 2b, what number can I take, or what number is a factor of both 33 and 3? Well, it's 3. So now my parentheses start. 3 times what is 3? Well, it's 1. And 3 times what is 33x? It's 11x. And I can double check my work by taking 3 times 1, which is 3, and 3 times 11x, which is 33x. Finally, on 2c, I have a 4 and a 35. They don't have any common factors, so I'm going to say it cannot be factored because they do not have, cannot be factored, because they do not have a common factor other than 1. Hopefully this video helped you get through some of the lessons in Chapter 7. A lot of it's review and just practice on those operations with integers, rational numbers, before we move on to the next level of algebra, which is solving equations and inequalities. So make sure you really grasp the ideas in Chapter 7. Don't just do the bare minimum. Push yourself to maybe try some additional problems out of the textbook. Ask for additional practice problems if you want. If you're just getting by with the bare minimum, then you're maybe not getting all that you can push your brain to do. So even on this last section, the first few problems are always pretty straightforward, but if you start getting into some of the later problems, you can see some challenge problems that you can use to push yourself a little bit further.